Today we'll discuss ISI's MSQMS QMA paper, and the first question is we need to solve this limit, and basically this is nothing but limit of sum. So we can write this limit as this limit L and then limit n tends to infinite, and we write it in this summation form. R varies from 1 to n, and this is r to the power 99 upon n to the power 100, which we can also write as this limit n tends to infinite 1 by n, and then this summation r varies from 1 to n r by n to the power 99. Now we'll take this summation in integral form. This 1 upon n is dx and r upon n is x. So this limit is actually this integral from 0 to 1 x to the power 99 dx, and which is x to the power 100 upon 100 from 0 to 1, which is 1 by 100, and that's your option B. Now in question number 2, we are given an expression with a condition that b is unequal to a plus c, then which of the following is true? Now what symmetry tells me is we'll take first and fourth together and second and third together, then we can write 1 upon a plus 1 upon c minus b plus 1 upon c plus 1 upon a minus b equals 0. Now this is c minus b plus a upon a c minus b plus a minus b plus c upon c a minus b equals 0. Now we can take this a minus b plus c common, so it will be a minus b plus c, and then it will be 1 upon a c minus b plus 1 upon c a minus b equals 0. Now clearly it is given that b is unequal to a plus c, so it cannot be 0. So from here the only condition that we get is 1 upon a c minus b plus 1 upon c a minus b, it must be 0. Now from direct comparison we can write a c minus b is equal to minus c a minus b, or 2ac equals ab plus bc, and if we divide it with abc we can write 2 upon b equals 1 upon c plus 1 upon a, that is abc. They are in HP, that means this option C is correct. Now in question number 3 we are given that abc are 3 distinct positive rational numbers and they are in AP, then roots of this equation ax square plus bx plus c are. Now I believe there is a mistake in this question, and this question actually should have been ax square plus 2bx plus c equals to 0, because in this form, if I take a very simple AP example as a as 1, b as 2 and c as 3, then we can take this as x square plus 2x plus 3 equals to 0. In this case, this d is 4 minus 12, which is less than 0. So then roots, they'll be imaginary. And if I take a counter example where we take these coefficients as 0.01x square plus 1.01x plus 2.01 equals to 0, it is clear that numbers are in AP. And if we find the discriminant will be 1.01 whole square minus 4 into 0.01 into 2.01, and it is 0.9397, which is greater than 0, in which case the roots will be real. This question is in fact wrong, and the standard version of this question which is available on the internet is this ax square plus 2bx plus c, where the answer will be, the roots will be imaginary. Now in fourth question we are given that AB equals 2a plus 3b, then the minimum value of a into b is, where a and b are both positive. Now from here we can write a into b minus 2, it is equal to 3b, or a is 3b upon b minus 2, and what we'll do is we'll subtract 6 and add 6. So it will be this 3 plus 6 upon b minus 2. Now we can write this expression y, which is AB as 3b plus 6b upon, and now here we add 12 and subtract 12. So we can write this as 3b plus 6 plus 12 upon b minus 2. Now if we differentiate this y with respect to b, we'll get dy by db, and will be this 3 and then minus 12 upon b minus 2 whole square, and if you put it equals to 0, we'll get b minus 2 whole square equals 4. Then b is either 0 or b is 4. We'll discard b equals 0. So we'll consider b equals 4, as in the question it is given that b is greater than 0. And if we find d square y upon db square, that will be 24 upon b minus 2 cube, where this value is positive. So that means this value will be minimum when b is 4. If b is 4 and we put it here, we'll get a as 6. So the minimum value of a into b is 24, and that's your option C. Now in question number 5, we are given this integral, which is this integral from minus infinite to 0, and we'll write this as e to the power x into e to the power x dx. Now here we'll let e to the power x as t, and if we differentiate, we'll get e to the power x into e to the power x dx as dt. So this integral will be simply this integral dt, and if we put this limit, now when x is minus infinite, e to the power minus infinite is 0, and e to the power 0 is 1, and if we put x as 0, e to the power 0, 1, so there will be this e. So value of this integral is e minus 1, and that's your option B. Now in question number 6, we are given this series, and we need to simplify this series. So what I'll do is, I'll multiply and divide everything with 1 minus a. So now I can write 1 minus a, and then 1 minus a into 1 plus a. So there will be 1 minus a square into b. Now this is 1 minus a, 1 plus a square, and there will be 1 minus a cube b square up to infinite. Now what I'll do is, I'll split this series in two parts. So it'll be this 1 minus a, and then I'll consider this first series 1 plus b square up to infinite, taking the first terms, and then from the second terms I'll take minus a common, and that'll be 1 plus ab square up to infinite, both of which are infinite GPs. Now this is 1 upon 1 minus a, and this is 1 upon 1 minus b, and it is minus a upon 1 minus ab. Now we'll simplify this. So it will be 1 upon 1 minus a, and this is 1 minus ab minus a plus ab upon 1 minus b into 1 minus ab. Now ab and ab will cancel, 1 minus a will also cancel. So this is 1 upon 1 minus b and 1 minus ab. So this correct option is this option C. Now in question number 7, it says P is the set of different terms obtained in this expression. So this expression is a plus b plus c plus z whole square. Now here the terms will be a square plus b square up to z square plus 2ab plus 2ac up to 2yz. Now number of terms in multinomial expansion, we have already done that. So here number of terms will be n, which in this case is 2, and r, which is 26, minus 1, c r minus 1, and there will be 27 c2, and it will be 27 into 13, which is 351, and this is your set P, and Q is this set which has a plus b plus 2 whole square. So here we'll have a square plus b square plus 4 plus 2ab plus 4b plus 4a. Now here we have to find set of elements in P which are not included in Q. So the elements in P which are also in Q is a square, b square and 2ab. So we have to subtract these three common elements. So in this case, number of elements will be simply 348, and that's your option A. Now in question number 8, we are given that fx is continuous at x equals 4, then we need to find the value of a and b. Now when x is less than 4, this is minus x minus 4, so it will be minus 1 plus a, and when x is greater than 4, this is plus 1, so it will be this 1 plus b. So if this function is continuous, then minus 1 plus a equals a plus b, and it will be equal to 1 plus b. Now here a will cancel, so we'll get value of b as minus 1, and here b will cancel, we'll get value of a as 1. So answer to this question is this option D. Now in question number 9, we have to find determinant of this matrix. So this is determinant n. We can write this one as log x base x, and this is log y base x, and this is log z base x. This is log x base y, log y base y, and log z base y, and the same way it will be log x base z, log y base z, and log z base z. Now we know that we can write log b base a as some log b upon log a. So here we'll take 1 upon log x common, and here we'll take 1 upon log y common, and here we'll take 1 upon log z common. Then we can write 1 upon log x, log y, and log z, and here will be this log x, log y, log z, and here also will be log x, log y, log z, and log x, log y, and log z. And basically value of this determinant is 0, and that's your option C. In question number 10, we are given that these three numbers, they are in AP. We have to find the value of x. Now this is 2 log basis 4, and this is 2 to the power 1 minus x plus 1, and this is log 5 into 2 to the power x plus 1 plus 1, and we can write 1 as log 2 base 2. Now this is 2 square, and we know that when power of base comes out, it comes out as reciprocal. So 2 upon 2 will cancel. So we'll have this as log to the base 2, 2 to the power 1 minus x plus 1, and log m plus log n is log m into n. So there will be 10 into 2 to the power x plus 2. Now log will cancel. We'll take 2 to the power x as y. So it will be this 2 upon y plus 1, and there will be 10y plus 2. You can write this as 10y square plus y minus 2 equals 0, which is 10y square plus 5y minus 4y minus 2 equals 0. So from here, the only positive value of y we'll get is 2 by 5. So 2 to the power x is 2 by 5, and if we take log to the base 2, we get x as log 2 by 5 base 2, and log 2 base 2 is 1, and log m by n is log m minus log n. So it will be log 5 base 2. So 1 minus log 5 base 2, and that's your option B. Now in question number 11, we are given fx, which is a quadratic polynomial, and one of the roots is minus 1. So what we'll do is we'll let fx as a x plus 1, and other root is suppose alpha. We need to find alpha. Now we are given that f minus 2 plus f3 is 0. Now f minus 2 is this a, and then minus 2 plus 1. So it will be this minus 1, and then minus 2 minus alpha, and a, and when x is 3, it will be 3 plus 1 4, and 3 minus alpha equals 0. So this is 2 plus alpha plus 12 minus 4 alpha equals 0, which is 3 alpha equals 14. So value of alpha is 14 by 3. So the two roots are 14 by 3 and minus 1. We need to find sum of roots. So there will be 14 by 3 minus 1, and there will be 11 by 3, and that's your option A. Now in question number 12, we are given this continuous function in 0 to pi, and we are given that f pi is 2, and we are also given this integral from 0 to pi fx. We'll multiply this sin x inside dx plus this integral from 0 to pi f double dash x sin x dx. Now we'll solve this first integral taking fx as first function and sin x as second function. So it will be this first function as it is, and integral of sin x is minus cos x from 0 to pi, and then minus this integral from 0 to pi will be this f dash x, and integral of sin x is again minus cos x dx, and plus it will be this 0 to pi f double dash x sin x dx, and we are given that it is equal to 5. So it will be equal to 5. Now here we'll put x as pi and x as 0. So it will be this f pi and cos pi minus 1, and then it will be minus 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 plus f0, and again we'll take this as first function and this is second function. So it will be f dash x sin x from 0 to pi and then minus this integral from 0 to pi f double dash x sin x dx plus 0 to pi f double dash x sin x dx, and it is 5. Now these two integrals, they'll cancel. Now sin pi is 0 and sin 0 is 0. So this is 0. So from here we'll get f pi plus f0, it is equal to 5, and we are given that f pi is 2. So from here we can clearly write value of f0 is 3, and that's your option D. Now question number 13, it says if x and y are distinct integers where x lying between 1 to 25 and y lying between 1 to 25, then the probability that x plus y is divisible by 5. So from these 25 numbers 1, 2, 3 up to 25, we have to select two distinct integers x and y, and that can be done in 25c2 into factorial 2 ways, and that will be 25 into 24, and that will be 600. Now we need to find this probability that x plus y is divisible by 5. Now what we can do is we can categorize them, or we can partition them according to their remainders when they are divided by 5. So when a number is divided by 5, it may leave the remainder 0, and which is when the numbers are 5, 10, 15, 20 or 25. Remainder 1, so there will be 1, 6, 11, 16 and 21. And the same way it may have remainders 2, 3 and 4, and each set will have 5 values. Now this sum will be divisible by 5 if either both of them they belong to this set. So in which case total number of ways will be 5c2 into factorial 2, or when one of them leaves the remainder 1 and the other one leaves the remainder 4. So in this case it will be 5c1 into 5c1 into 2 or 2 factorial, and the same way if one of them leaves the remainder 2 and the other one leaves the remainder 3, and it will be 5c1 into 5c1 into factorial 2. Now it will be this 2 into, now 5c2 is 10 and this is 25 plus 25, so it will be 60. 60 into 2 is 120. So this required probability is 120 divided by 60, and that's your option D. Now question number 14 is very simple. We are given z, and this is log base 2, and this is log 4, 256. 256 is 4 to the power 4, and plus log, and this is 2 to the power 1 by 2, and this is 2. Now log 4 base 4 is 1, and here will be log 4 base 2. So it will be this log 2 square base 2, and here power of base comes out as reciprocal. So this is 1 upon 1 by 2, and log 2 base 2 is 1. Now here log 2 base 2 is 1, and here also it will be log 2 base 2. So this is 1 plus 2, and that will be 3, and that's your option B. Now question number 15 is a conditional probability question. It says a bag contains 4 red and 6 black balls. Now a ball is drawn. Now this drawn ball, it can either be red or it can be black. Probability of drawing a red ball, it is 4 by 10, and black ball is 6 by 10. Now it says a ball is drawn, its color is observed, and this ball along with 2 additional balls of the same color is returned to the bag. So now the bag has, in the first case, 2 more red balls. So there will be 6 red and 6 black. And the second case, it will have 2 more black balls. So now it will be 4 red and 8 black. Now it says if another ball is drawn at random, find the probability that this ball is red. So we have to find the probability that this ball drawn is red. Now from this box, probability of getting a red ball is 6 by 12, and here this probability is 4 by 12. So the probability that this second ball is red is this into this 4 by 10 into 6 by 12 plus 6 by 10 into 4 by 12, which is 48 by 120. Now this is 4 by 10, which is 2 by 5, and that's your option D. Now in question number 16, it says a fair coin is tossed 100 times, find the probability of getting odd number of tails. It can be this one tail, so it will be 100 C1, P to the power 1, Q to the power 100, so there will be 1 by 2 and 1 by 2 to the power 99, 100 C3, 1 by 2 cube, 1 by 2 to the power 97 up to 100C99 1 by 2 to the power 99 into 1 by 2. So here we can take 1 upon 2 to the power 100 common. So there will be 100C1 plus 100C3 up to 100C99, and this is 1 by 2 to the power 100. Now we know that NC1 plus NC3 plus NC5, which is sum of all odds, is 2 to the power n minus 1. So there will be 2 to the power 99 upon 2 to the power 100, which is 1 by 2, and that's your option C. Now question number 17 is a very standard question. Now in this question, what we do is we write fx plus f1 minus x. Now this is 9 to the power x upon 9 to the power x plus 3, and here will be 9 to the power 1 minus x upon 9 to the power 1 minus x plus 3. Now we can express this as 9 to the power x upon 9 to the power x plus 3, and this is 9 upon 9 to the power x, 9 upon 9 to the power x plus 3. So it will be this 9 to the power x upon 9 to the power x plus 3, and here it will be 9 upon 9 plus 3 into 9 to the power x. Now we'll divide everything with 3. So now it will be this 9 to the power x, 9 to the power x plus 3 plus 3 upon 9 to the power x plus 3, and if we add them, it will be equal to 1. So that means sum of fx and f1 minus x will be 1. Now if we take these pairs, first one and the last one, we know that its sum is 1. In the same way, second term and second last term will also be 1. So each pair will result in the sum 1, but we have odd number of elements. So here what we'll do is sum of this series fr upon 1996 LB. Now total number of terms is 1995, where 1994 terms they'll be paired. So for each pair sum is 1. So total number of pairs will be 1994 divided by 2, which is 997, and plus we have this one term which is the middle term. And what is the middle term for this? Middle term for this will have value as 1 by 2. Now what's f1 by 2? f1 by 2 will be 9 to the power 1 by 2 3 upon 3 plus 3, which is 1 by 2. So there will be 997.5, and that's your option B. Now in question number 18, we are given that 2 6-face dice are tossed by the probability that total score is a prime number. Now prime numbers are 2, 3, 5, 7 and 11. Now we'll have this sum 2 when it is 1 1, 3 when it is 1 2 2 1, it is 5 when it is 1 4, 2 3, 3 2 and 4 1. It'll be 7 from 1 6, 2 5, 3 4, 4 3, 5 2, 6 1, and it'll be 11 when it is, now this is 1 plus 2 3, 7, 13, 14, 15. Total number of favorable cases is 15. So this probability will be 15 divided by total number, which is 36. Now this is 5 by 12, and that's your option B. Now in 19 it says if the area bounded by these two curves is 1, then the value of k is. Now we have these two curves, and it says area bounded by them is 1. Now first we'll find their point of intersection. We'll square this one. We'll write y square as k square x to the power 4, and we can write this y square as x by k. Now this is x cube equals 1 upon k cube. That means value of x is 1 by k. So this point of intersection is 1 by k. Now we can write this area. It will be this integral from 0 to 1 by k, and then y of upper curve. So it will be under root x by under root k minus y of lower curve, which is kx square into dx. Now this is 1 upon under root k, and here will be this x to the power 3 by 2 upon 3 by 2 from 0 to 1 by k, and minus k, and will be this kx cube upon 3 from 0 to 1 by k, and this area it is given as 1, so it will be 1. Now if you put x as 1 by k, so we get this as 2 by 3 k square minus 1 by 3 k square equals 1, or k square equals 1 by 3. That is value of k is 1 by root 3, and that's your option B. Now in question number 20, we are given this equation where alpha and beta, they are both positive, Then it says for what value of alpha and beta this equation will have distinct roots. Now what we can do is we can write this as x square minus alpha x plus beta equals 0. Now the easiest way is to check these options. If we take alpha is 5 and beta is 4, we write x square minus 5x plus 4 equals 0, which will give us x minus 1, x minus 4 equals to 0. That is, we'll have two real and distinct roots. So that means the correct option is this option A. Now question number 21, it says find the last digit in 7 to the power 300. Now we know that 7 to the power 1, last digit is 7. 7 square, 49. 7 cube, 3, 1. So we'll repeat this pattern after every 4 numbers. So this 7 to the power 300 is actually 7 to the power 4 to the power 75. Now here we'll have last digit as 1 and 1 to the power 75 will always be 1. So last digit of 7 to the power 300 will be 1, and that's your option A. Now in question number 22, we are given this series. And we can actually write this series as this summation 2r upon 2r plus 1 factorial, where r varies from 1 to infinite. Now what we'll do is we'll add 1 and subtract 1. So we can write this as this summation r varies from 1 to infinite and will be 1 upon factorial 2r minus 1 upon factorial 2r plus 1. Now if you put r as 1, we get this as 1 upon factorial 2 minus 1 upon factorial 3 plus 1 upon factorial 4 minus 1 upon factorial 5. And if we add 1 and minus 1 to it, it is nothing but the expansion of e to the power minus 1, and that's your option A. Now in question number 23, we are given this matrix equation and says for what value of p the system of equation does not have a unique solution. And we know that it will have a unique solution if determinant is unequal to 0. So for non-unique solution, this determinant, it should be 0. So this is minus 5, minus 6, 3, minus 3, 6, p, and 11, minus 6, minus 5, and it should be equal to 0. Now what we'll do is we'll write r1 as r1 plus r2, and we write r2 as r2 plus r3. So we can write this as minus 8, 0, p plus 3, and here will be 8, 0, p minus 5, and this is 11, minus 6, minus 5 equals 0. Now we'll expand it about this second column. So we'll get this as minus 8, p minus 5, and then minus 8, p plus 3 equals 0. So we'll have 2p minus 2 equals 0. That is, value of p must be 1, and that's your option A. Now in question number 24, we are given this matrix P. We have to find some of this matrix series. Now if we look at P square will be 0p 0 0 into 0p 0 0. Now we multiply them, it will be 0 0 0 0. That means it is a nilpotent matrix of order 2. So that means P square P cube up to p to the power 21, they'll all be null matrix. So value of this series will be simply I plus p. Now I is an identity matrix 1 0 0 1, and this p is 0p 0 0. So some of the series will be 1p 0 1, and that's your option B. Now in question number 25, it says there's a cylinder manufacturing company who has decided to outsource surface hardening process to one of the 5 shortlisted heat treatment companies. Now each company has been given 100 pistons for hardening, and it says any rod with unsatisfactory surface hardness will be rejected. The number of rejected rods is less than 10 for each company. If the median rejection is 5 and mode is 6, what is the maximum number of piston rods that can be rejected for a single heat treatment company? Now we have 5 rejections, say x1, x2, x3, x4 and x5, and each of xi is less than 10, and suppose we have arranged them in an increasing order. Now it says median rejection is 5, so that means this x3 will be 5, and it also says mode is 6. Now mode can only be 6 if at least 2 of them they are 6. So here x4 and x5 they must be 6, and x1 and x2 they'll be less than 5. So the maximum number of piston rods that could be rejected for a single heat treatment company is 6, and that's your option B. Now in question number 26 it says there is a Poisson distribution with lambda greater than 0 and probability of x equal to is equal to probability of x equals 3. Now we know that probability of x equal to 2 is e to the power minus lambda into lambda to the power 2 upon factorial 2 and will be equal to e to the power minus lambda to the power 3 upon factorial 3. Now e to the power minus lambda will cancel, lambda square will also cancel, so value of lambda will be 3 and that's your option C. Now in question number 27 we are given this un which generates this sequence. First what we will do is we will find the value of a, b and c. Now if we put n as 1 we will get a and a will be equal to 4. If we put u as 2 we will get a plus b. This part will be 0 and that will be equal to second term which is 11. And if we put a as 4 we will get b as 7. And if we put n as 3 we will get this as a plus 2b plus c and that will be equal to 24. Now a is 4, this is 14, 18, value of c is 6. So basically your un is 4 plus 7 n minus 1 plus 6 into this value. So it will be this 3 n minus 1 n minus 2. Now there are overall 101 terms. We have to find median of the data generated. Now clearly it is an increasing sequence. Now in this increasing sequence, middle term or median will be at n plus 1 by 2 term. So it will be 101 plus 1 by 2. There will be 51st term. So we have to find its median and it will be u51. So it will be 4 plus 7 into 50 plus 3 into 50 into 49. And that will be 7,704 and that's your option A. Now question number 28 is we are given this expression which is 9 10 theta plus 30 plus 6 10 theta minus 30 and it says if it can be written in this form then find the value of P and Q. Now this is 9 and it is 10 theta plus 10 30 is 1 by root 3 and here will be 1 minus 1 by root 3 10 theta plus and this is 6 10 theta minus 1 by root 3 upon 1 plus root 3 10 theta. Now in the denominator power of 10 theta will be 2, so that's not a problem, but in the numerator also the highest power of 10 theta can be 2, it cannot be greater than 2. But here if we look at this question, if we multiply this here, it will be 15 10 theta into 10 square theta, there will be 10 cube theta. Now there should be no term containing 10 cube, that means value of q should be 0. In the same way there should be no 10 square theta, that means this p it should also be 0. But then none of the option contains 0 as an option. So we cannot write this expression in this form. So this question is definitely wrong. Now in question number 29 they have asked for sum of rational terms in the expansions. We write general terms, so it will be 10 CR 2 to the power 1 by 2, 10 minus R 3 to the power R by 5. So there will be 10 CR 2 to the power 5 minus R by 2 and 3 to the power R by 5, where R takes the value from 0 to 10. Now R should be divisible by 2 and it should also be divisible by 5. That means R has to be divisible by 10. So there are only two values that stand out, 0 or R can be 10. So sum of these two terms, there will be 10C0 2 to the power 5 3 to the power 0 plus 10C10 2 to the power 0 and 3 to the power 2. Now this is 32 plus 9 which is 41 and that's your option B. Now in question number 30 it says a bag contains 9 red, 4 white and 3 blue marbles. One marble is picked at random. Find the probability that marble will be red or blue. So this probability is very simple. It can be either red, so there will be 9C1, or blue. There will be 3C1 out of 16C1 and that is 12 by 16 which is 3 by 4, the option C.
Hello and welcome to the world of mathematics. I present my website www.mathsmarazine.com and my YouTube channel Maths Marazine for your kind perusal. If you like them and are inspired by the possibilities, then consider subscribing and sharing it with someone you know who might benefit from it. Thank you.